Okay, so this is just a continuation from the previous slide. So we have seen that for the node X, the iter increases by at least 1. If the iter increases by at least 1, what happens to its potential? By 1, 5 falls by 1, right? Because the term that we have is minus iter of X in phi q of X, right? So it's a fall by 1. So the question is now, how many nodes have such falls? So we have seen that all nodes except last nodes with some level value have phi drop by -1 or still more. And so the question is, how many such nodes are there except last node? So how many last nodes? Now we know that level X only takes certain values. This we know to be greater than or equal to 0 and less than or equal to alpha n. So alpha n minus 1. So there are going to be alpha n such nodes at the most. That is, we are talking about the last nodes with a particular level. So as there are alpha n distinct levels, there can be at the most alpha n such nodes. So here we come back to a count of how many nodes have a change in potential. So how many nodes? There were S in all. Then we subtracted 2 because of leaf and root if they are there. Then we again subtract alpha n because they are the last nodes of level value. Okay, so that is the reason behind this. All of them are going to have at least a -1 drop. Okay, so given that, now we can say that our CLRS is equal to action cost OS plus fall in potential, that is -1 into O S minus alpha n plus 2. So this gives rise to order of alpha n plus 2, which is the same as order of alpha n. Now we have already seen what is the maximum value of alpha n. It is less than or equal to 4 practically. We cannot imagine bigger values of alpha n or for any n. So it means that, hence, what is the final takeaway? Path compression heuristics plus rank DOD in heuristics results in O alpha n amortized cost of each operation in the worst case. So that is what makes the path compression and rank union heuristics so useful, and they are very often used in disjoint sets. Disjoint sets are used for many applications. So thank you. With that we come to the conclusion of the chapter on disjoint sets. Thank you.